This is a great question that gets you using implicit differentiation in order to solve the monopolist problem. Now remember, with a monopolist, they can affect prices. In fact, they can set prices if they want to. Now we're not going to do it exactly like that in this problem, but the quantity they produce affects prices. So they're not a price taker, right? Not a price taker. And they have an inverse demand function that we're going to define generally as P of Q. So you could think of the demand function is a function of price. And what have we done here? Well, we've essentially found the inverse function. So the inverse demand function. We've said, no, let's move this thing around and let's redefine it. So we've got P as some function of Q, which we're just going to define as P of Q. So we're going to use the inverse demand function. That means if you tell me the quantity, the inverse demand function will tell you the price. Now this monopolist face a constant average cost of K. So that's going to make our work easier. So they have an average cost per unit of K, some constant. So this is going to be a constant. And it's going to be positive. It's going to be greater than 0. Negative average cost is a bit of a nonsense example. We want to write down the profit function and find the necessary first order condition that will maximize this monopolist profit. And so we're going to find some value for Q, or some expression for Q that will maximize their profit. Remember, generally, profit is equal to revenue minus cost. And so we're going to use the information above to fill in for revenue. Well, revenue is price times quantity. So there's our revenue. Not too hard, as long as you know what you're doing. You can do it quickly. Minus cost. Well, what's their cost here? Well, we know that each unit of output, each unit of Q, costs K. So cost is just going to be K times Q. Now we want to find the necessary first order condition for an extreme value. And we know the first order condition is that the slope should be equal to 0. So we're going to take the derivative of profit, and let me redefine it as pi. So we're going to take the derivative of profit with respect to Q. And we can see pretty clearly here that price is a function of Q. And so we've got to use our product rule here. We've got P prime Q times Q plus P of Q minus K. And if we want to find an extreme value, if we're trying to find the profit maximizing value of Q, we need to set this thing equal to 0. And we could say something like, suppose in Econ 1000, you were told that the monopolist sets marginal revenue equal to marginal cost. Well, we know from this above that the marginal revenue is P Q plus price. And marginal cost is just equal to K, which also happens to be equal to average cost. In this example, it doesn't have to be, but in this example it is. And so we could rewrite this expression as marginal revenue is equal to marginal cost. What is this doing? This maximizes profits of a monopolist. And maybe I will just add a little star as a superscript to the Q's, where the star represents equilibrium. Or the Q that maximizes the monopolist's profit, or another way of putting it, the Q that solves the monopolist problem. The next part of our question is asking us, how does the equilibrium quantity change when the average cost, that constant average cost term, changes? Now, we know that Q star depends on K, and price depends on Q, and Q star for that matter. So we're going to try and take the derivative, or we are going to take the derivative of this expression, both sides, with respect to K. So maybe I will write that out. So we're going to take the derivative with respect to K of P prime So there is how we're going to take, or that's sort of explaining us to take the derivative of both sides with respect to K. Now I'm going to go ahead and do that. So we're going to start off with the product rule, and we have P double prime Q star times however Q star changes with K plus, well, what's the derivative of that thing there? It's just going to be 1, but also times how Q star changes with K. Oh, maybe we don't need a bracket there. I'll just write P prime Q to finish the product rule plus P prime Q star times the change Q star with respect to K is equal to 1. And it looks like I just missed a Q star here in the first term right here. Now what do we want to do? Well, we're asked to find how a change in K affects the optimal quantity of production. So let's solve for the change in optimal quantity with respect to a change in the average cost. Where do we find this change? It's right there, it's right there, and it's right there. And notice that, oops, oh no, that's right, yeah, these two are the same. So I can rewrite this Q star P double prime two, and I can choose how I want to write it. P Q change in Q star over change in K is equal to 1. And not too bad, because this is the thing that I'm solving for. So I've got them all on the left-hand side. Every term that includes one is on the left-hand side. Only this one term, the one term on the right-hand side, has none of these changes in it. So I will simply factor out, maybe I will do it in 2 steps. I'll factor out the change in Q star with respect to K. And I just forgot my 2 right here, so I've got the 2. Now, notice that, I made a mistake here again. I shouldn't have that there. I moved it out of the bracket. And we can easily solve for the expression of interest. We've got the change in the equilibrium quantity with respect to average cost is equal to 1 over Q star P double prime Q star plus 2 P prime Q. And I just forgot some stars on my Q's, which I'll add there. Now it's hard for us to interpret this expression because we're not really sure what these derivatives look like, but one would suspect that if the average cost increases, the optimal quantity goes down. Let's look at our last part of this problem, part C. How would a change in the average cost affect the firm's profit? So before we were looking at how the optimal quantity produced would change if average cost changed. How would the firm's profit change? So let's start by rewriting the firm's profit function as a function of Q. Now let's see how profit changes with K. Remember that Q depends on K. Of course, price depends on Q. And we're really interested in the monopolist's profit at equilibrium. So we could add stars to our Q's to make that a little bit clearer. And what do we have? Well, we have P prime, Q star, K. And we need a Q star right there. And the change in K with respect to K is just 1. So we get Q star. I could add a 1 there to remind you where that's coming from. Minus change in Q star with respect to K times K. Now what can we do with this? It's kind of a mess. Well, remember that in equilibrium, if profit is maximized, then the change Q star with respect to K should be equal to 0. That is to say, in order for Q star to be an extreme value, a maximum, this condition must hold. Well, let me try rearranging our expression here. And not so much rearrange it, but let me factor out our changes in Q star with respect to K. I see I missed a little D there. We can rewrite this, and I've got P prime Q star times Q star plus P Q star minus K. And minus the Q star that remains right here. Notice that in part A, we showed, we showed that P prime Q star plus P Q star minus K had to be equal to 0 for Q star to be a maximum, well, I shouldn't say maximum point, to be a critical point. And that means if I rewrite this we're going to get essentially the change in Q star with respect to K multiplied by 0 minus Q star. And what are we left with? Well, the change in the monopolist profit with respect to a change in K is equal to negative Q star. So we can kind of see here, so sort of a surprising result that the change in profit would be equal to such a simple answer, negative the optimal amount of quantity produced in equilibrium. But we can definitely see here that an increase in K is going to lead to a decrease in profit.